All right, you'll recall, if you haven't already, I do a nomenclature bit with this molecule. I would like you now to draw me the most stable, the most stable conformation of this molecule in Newmann projection form, looking down the C2, C3 bond, so C2 in front. All right, go away and do that. Most stable conformation, looking down the C2, C3 bond. All right, if you're back, we just did this numerical thing, and the nomenclature bit found that we number, if you don't understand why I number it in the order I do, go check out the nomenclature question. This is carbon 2, put your eye there, draw carbon 2 in front. All right, so if I'm looking there, looking here, there's a methyl group down. It's a tetrahedral atom, so anytime you look right on a tetrahedral atom, you'll have a kind of a Y on a circle. The bromine is sticking out at you. Looking this way, that would put the bromine over here. And there's an H not shown going back the other way. All right, that's carbon 2. On carbon 3, we've got an OH, an isopropyl, and an ethyl group, right? And so most stable will be staggered. So put those there. And in fact, if you're looking this way, right, this propyl group, right, 3 carbons coming off of C3 would be up. If I'm looking this way, this would be going back away. So this is in propyl. And as I say, you have to indicate all the atoms. You have to take care of everything. So this is an in propyl group. Isopropyl would be down towards you. So this is an isopropyl. And the OH is back into the plane of the board. All right, so that's a Newmann projection. Is it the most stable? So again, if you looked at the tutorial, you want to put the big group on the front carbon, anti to the big group on the back carbon. So what's the big group on the front carbon? Well, it's actually kind of a toss-up. Bromine and methyl are about the same size. Bromine is a much bigger atom. Honestly, I shouldn't have had a bromine on here. That's tricky. Bromine's a big atom, but it's only one atom. A methyl is a smaller atom, but it's got 3 protons coming off of it. And in point of fact, if you actually go in and measure, they're really close to the same size. There's some really subtle stuff. The carbon-bromine bond is a lot longer than the carbon bond, and so this bromine kind of sticks farther away, gives it a little more space. Really, if I give you a problem like this on a test or a quiz in class, I don't really care which one of these you pick at this point. But what about the back group? In-propyl versus isopropyl. They're exactly the same size, right? C3H7. So they should be the same size. But it turns out this one's a little bulkier because, you know, if this is long and thin, it can sort of get most of itself out of the way. This one's sort of shorter and fatter, and so it's harder. Speaking as sort of a largish guy, not short necessarily, but it's kind of hard for me to fit into a space. Whereas if you're thinner, you can stick your legs out, get it away. So it turns out an isopropyl group cuts out a bit more area. Either way, the front carbon, the big group, is either the bromine or the methyl. Let's just go ahead and say that it's the methyl. All right, so it's anti to the N-propyl group. If N-propyl was bigger than isopropyl, we'd be done, but we're not. So the big group on the back carbon is isopropyl. So we need to rotate this. So we need to rotate around to where the isopropyl is up here. So that's going to push the N-propyl down to there, and the hydroxyl over to here. Okay, and so then I'll draw this over here. Again, I'm going to keep the front carbon the same. Right, so isopropyl comes up to the top, N-propyl comes down to the right, OH comes over here. Keep them in the right order. This would be the most stable conformation in the Newmann, as drawn in a Newmann projection. These will actually be pretty close, but the second one's a little more stable.